Hi. Welcome back. In our last class, we learnt Dynamic Host Configuration Protocol. In today's class, we will be learning Domain Name System, DNS. The Domain Name System, DNS, is often referred to as the phonebook of the Internet. It is a hierarchical and decentralized naming system used to translate human-friendly domain names, like www.example.com, into IP addresses, like 192.0.2.1, that computers use to identify each other on the network. Definition and purpose of DNS. Domain Name System is a service that can equally be seen or enables you to translate human-readable information to IP address or translate to figure. Purpose. The main purpose of DNS is to make the Internet more user-friendly by simplifying access to websites. Users don't have to remember IP addresses. Enabling domain-based navigation across the web. Allowing scalability for the Internet by distributing the responsibility of name resolution across a global network of servers. Types of DNS. 1. Authoritative DNS. Definition. An authoritative DNS server holds the actual DNS records, like a MX name, for a specific domain name. It's the final source of truth in the DNS resolution process. Purpose. It answers queries with the correct IP address for a domain, but only for domains it is responsible for. Example. If you're visiting example.com, the authoritative DNS server for example.com responds with its correct IP address. 2. Recursive DNS. Definition. A recursive DNS resolver is a server that takes a user's DNS query and does the work of finding the IP address by querying other DNS servers, root, TLD, authoritative. Purpose. It acts on behalf of the client to resolve the domain name, caching responses to speed up future requests. Example. When you type example.com in your browser, your ISP's recursive DNS server receives the request and resolves it by asking multiple DNS servers until it finds the answer. Importance of DNS in networking. 1. Human-friendly naming. DNS translates human-readable domain names, like example.com, into IP addresses, like 192.0.2.1, that computers use to identify each other on the network. 2. Scalability. DNS supports the vast number of websites and services on the Internet, providing a distributed and hierarchical naming system. 3. Load balancing and redundancy. DNS can direct users to different servers, e.g., based on location, improving performance and availability. 4. Email routing. DNS records, like MX records, determine where emails should be delivered, making it essential for email services. 5. Security enhancements. Protocols like DNSSEC help protect against spoofing and cache poisoning. DNS hierarchy and structure. The DNS hierarchy and structure is organized in a tree-like format with different levels of domains. 1. Root level, dot. The top of the DNS hierarchy, represented as a dot symbol, though usually not typed. Managed by root servers. 2. Top-level domains, TLDs. Directly below the root. Examples, .com, .org, .net, .edu, country codes like .uk, .in. Managed by registries like VeriSign, for .com. 3. Second-level domains. Registered by individuals or organizations. Example, in example.com, example is the second-level domain. 4. Subdomains. Optional parts added to the left of the second-level domain. Example, www.example.com or mail.example.com. 5. Hostnames. The final part is used to identify specific devices/services. Often overlaps with subdomains. Each level points to the next using DNS records, and this hierarchical structure ensures scalability, manageability, and decentralization. DNS resolution process. The DNS resolution process is how a domain name, like www.example.com, is translated into an IP address. Here's a step-by-step breakdown. 1. User request. The user types a domain name into a browser. 2. Check local cache. The system first checks the local DNS cache to see if it already knows the IP address. 3. Query to recursive resolver. If not cached, the request goes to a DNS recursive resolver, often operated by the ISP or a third party like Google or Cloudflare. 4. Root server contact. The resolver asks the root server for the location of the TLD server, e.g., for .com. 5. TLD server contact. The root replies with the TLD server, and the resolver then asks this TLD server for the domain's authoritative name server. 6. Authoritative name server. The TLD server responds with the IP of the authoritative name server for the domain. 7. Final IP retrieval. The resolver queries the authoritative server, which replies with the IP address of the requested domain. 8. Return to user. The resolver returns the IP address to the user's browser, which then initiates a connection to the web server. 9. Caching. The IP is cached locally for future requests to improve speed. How DNS browse traffic to a web application. How DNS works. 1. A user opens a web browser, and enters a domain name in the address bar. 2. The request, query, will be sent or routed to a DNS resolved, and the DNS resolved is found and managed by the ISP. 3. The DNS resolver from the ISP forwards the request to a root name server. 4. From the root name server, the TLD will try to be located, TLD, top-level domain. 5. The DNS resolver for the ISP would now choose a particular name from the names produced, and then send it to the name server. 6. The DNS server scrutinizes the set of names brought before it, and then seeks to match the query. As soon as it finds it matches, it will extract the value, which is the IP address. 7. The DNS resolver for the ISP finally finds the IP addresses that were requested for and then returns the value to the web browser. Note, as the DNS resolver gets the IP address and sends it to the web browser, it also saves it automatically for a temporary period of time known as TTL, time to leave. Thank you for listening. See you in the next class.